In this video, I will give you some insight on how to implement a system where enemy AI can remember your location and share that location with others. So this works as follows. Enemies will see the player or hear the player's gun or an enemy alert, and they will then search that location for the player. When an enemy loses the player, that player's location is added to an array, which the enemy searches through from the most to the least recent sighting. Enemies can also share information when they see another enemy AI, and that AI is within a certain distance from them. This system could be utilized in stealth-type games, where alerting one enemy alerts all of them, or a certain number of them within range, as is the case here. As you can see, shooting causes the enemies to hear me and immediately rush to my location. Once they see me, they play an alert which makes other enemies rush to the location of the enemy who alerted. You'll also hear another sound, and as you can see in the log, enemies are sharing knowledge of the player's location or of locations where they heard a sound with each other. Now let's look at the logic behind this functionality. So first, in the enemy character header file, I've added the public FVector properties, heard location and currently searching. Heard location stores the location of a noise event when the enemy hears one, and currently searching stores the location the enemy is searching at that time. I have also added a public function, shareLocation, which takes a location and the name of the enemy who is sharing it. This is accessed by foreign enemy AI to pass the location variable when available. I also added the private function addLocation to memory, which adds the given FVector where the player was last seen to the private T array of FVector's last known locations, which stores up to 5 different locations where the player was lost after being chased by the enemy. Now moving to the CPP file where all the functions are implemented. First, I initialize the necessary FVectors as 0 vectors in the begin function because they can't be initialized as null pointers, and it is unlikely that the player will ever be at exactly 0, 0, 0 in the world. Then at the end of the tick function, I've added logic that clears the currently searching variable once the location is reached. The first if statement checks if there are any values in last known locations, and then finds the distance between the enemy's location and the location of the nearest node to the location being searched, checking if it is nearly 0 with some tolerance, as it is unlikely to be exactly 0. Then if the location being searched is the top or most recently added location in last known locations, that vector is removed from the array by calling the pop function, which removes the most recently added value in the array. Then the currently searching vector is set to a 0 vector to reset it as nothing is currently being searched. Now the modified version of the agent patrol function shows how the AI is made to move to these locations to search them. So if the heard location is not a 0 vector, in other words if the enemy has heard a noise, and if the currently searching variable is not that location, then the path they are on is emptied using the empty function to clear the path array, logging the new location to the editor log, and then setting the currently searching location to where the noise was heard, and then resetting the heard location to 0 so that the AI doesn't keep updating it. That takes priority over locations the player was last seen, because I thought it would be more realistic, as a loud sound would alert an enemy more than losing the player in a certain area. This else if statement is similar to the previous if, in that it checks if there are any locations the player was seen and lost, and if they aren't currently searching the most recent one, then it empties the path, logs the location, and sets currently searching to the most recent location the player was spotted, and sets the destination node to the nearest node so that the AI can move to it. If neither of these conditions are met, then a random node for the AI to travel is generated as normal. I'll try not to say too much about sense triggered, but I will explain a few things. So here, when the enemy sees an actor, they check if the actor is not a null pointer to prevent errors when dereferencing it, and then I use the getName function, which returns the actor's name to differentiate between player and enemy actors. So if the returned name contains the text in the text macro, in this case player, it will know to perform the following actions. First, log the sighting as well as the enemy who saw the player, alert allies, then alerts the enemies in range, and then the detected actor and can-see actor are updated as normal. On the other hand, if the sensed actor is an enemy, then it does this. So that last known locations check in the if statement is actually redundant, but I forgot to remove it, so just ignore that. It then checks the distance between the enemy's location and the sensed enemy's location, and checks if the float returned is under 1000, which I think is around 10 meters or something, which is arbitrary, but it seemed to work. So then an F vector, toShare, is defined by the binary statement that checks if last known locations has no values, in which case toShare is set to the currently searching vector. Otherwise, it's set to the most recent location the enemy lost the player at. Then an if statement checks to make sure the location to be shared between the enemies is not 0. If so, the sensed actor is cast to an A enemy character class. This is because sensed actor could be any actor, and this casting allows me to access the functions from the A enemy character class of sensed actor. Then I checked that the script variable wasn't null, so the cast worked. And if it's not null, I dereference it and access the share location function in it, and pass the location to share and the name of the enemy sharing it to the receiving enemy. Further down we can see how the hearing sense works, in that it logs that a noise was heard and sets the heard location to the location of the stimulus, which is in this case a hearing sense stimulus, and this code gets the enemy to search that location. Otherwise, if the detection was unsuccessful and the detected actor isn't null and is the player actor, then the player was lost. So here I log this and which enemy lost the player, and add the location the player was last seen to the array so the enemy AI can search it and share it with others. Then obviously detected actor is set to a null pointer, so the location of the player is not constantly updated without the player being seen by the enemy. Now here in the share location function, an if statement checks that the receiving enemy is not currently searching an area, and that the last seen player locations array does not contain the location that was shared by the other enemy. If so, a sound is played and the share is logged to the editor log in red text to differentiate it from the other logs. And the shared location of significance is added to the receiving enemy's array. Finally, the add location to memory function does just that. It adds player locations to the TRA last known locations. First, it checks if there are more than 4 values in the array. This is to limit the array to 5 values, as after this, a for loop shifts each value in the array back by 1 index, overriding the oldest value in the array. 5 is just an arbitrary amount of locations the enemy can remember. It could be any number you want, but I thought it was more realistic. So anyway, the shifting works by setting the current index value to the value at that index plus 1 place. And after that, the top or most recent location in the array is overridden with the new value to be added to the array. Effectively, this just overwrites the oldest value and adds the newest one without dealing with the .remove function, which can cause out-of-bounds exceptions when used in for loops. Otherwise, if there are less than 5 values in the array, it simply adds the location to the end or top of the array and logs that the location was added. So that's how it works. I hope this video helped. Maybe you can improve on my design, because there are many applications for systems like this to share information between AI and record player locations in memory to search them.